The change from Pohoihoi crust to A'a crust as a flow moves down steep slopes and cools is well known. It can easily be seen along this small flow, which initially emerged as Pohoihoi and is now forming A'a at its front. A'a and Pohoihoi flows are defined by their crust, which cannot change once it is formed. However, the fluid lava carried by the channel has neither form and can change continuously depending on viscosity and shear stress. Some A'a flows that slow down when they reach flat ground actually produce Pohoihoi flows. Other stagnated A'a flows can leak viscous, spiny Pohoihoi. This A'a flow gradually underwent a change to slabby Pohoihoi and finally to Pohoihoi as it moved onto flat ground. The crust growing over the channel is keeping the lava hot and fluid, so Pohoihoi can form at the front of the lava flow. Basaltic eruptions begin as fissures, which erupt enormous amounts of lava. Because the volume of lava is widely distributed over a half-mile or more of vents, many of the flows move slowly and initially form Pohoihoi. As the fissure eruption progresses, small spatter cones and ridges, called spatter ramparts, build along the sides of the vents. If the eruption lasts long enough, generally a few weeks or months, the site of eruptive activity will localize to a single vent. Forcing the lava out through a single narrow vent creates a nozzle effect, like putting your finger over the end of a garden hose. Sporadic eruptions from these narrow vents create spectacular high fountains that can spray lava up to 2,000 feet into the air. When lava ponds within the cone, Pohoihoi flows typically form near the vent. As they move away from the vent and cool or encounter steeper slopes, the Pohoihoi flows change to A'a flows. After many high fountain events, Hawaiian eruptions produce large craterless cones when lighter material piles up on the downwind side of the vent. At craters of the moon, many of the vents were formed by Hawaiian-style fountaining and are marked by large asymmetric hills of cinder with no apparent crater or vent. Sustained eruptions with low effusion rates form gently sloping shield volcanoes. Repeated overflows of Pohoihoi coat and recoat the surface of the shields. Overflows within a mile or so of shields and lava lakes produce another variant of lava called shelly Pohoihoi. These flows have a relatively thick yet remarkably flexible crust that detaches from the underlying molten lava and folds into billowy forms with hollow interiors. Shelly Pohoihoi lava is full of bubbles and is more than 50% gas by volume. Gas escaping from the molten interior creates even more hollow space beneath the buckled crust. On flatter ground, shelly Pohoihoi can pile up into thick stacks of flat crustal plates. Repeated eruptions of fluid lava can build enormous shield volcanoes. Mauna Loa, the world's largest volcano, rises nearly 30,000 feet above the surrounding seafloor. Eruptions of more viscous basaltic lava produce pulsating strombolian explosions. The higher viscosity is due to either the original magma composition or to cooling in the magma chamber prior to eruption. Gases cannot easily escape from the sticky lava and accumulate until large bubbles form and burst from the vent. Strombolian eruptions are powerful and make a lot more fine ash than Hawaiian eruptions. The individual blasts toss dense cinder and bombs, which are not strongly affected by regional wind patterns. Strombolian eruptions construct beautiful circular cones with central craters. Some cinder cones have a distinct horseshoe shape that is produced when cinder lands on the active lava river exiting the vent and is swept away. Strombolian eruptions strongly favor the formation of flows, like these large sheets of surrounding Bandera crater.